In this lesson, we're going to learn how to solve problems using an equation in slope-intercept form. So the Student Council sponsored a dance. A ticket cost $5 and the cost for the DJ was $300. Write an equation for the profit, P dollars, on the sale of T tickets. So if we think about slope-intercept form, that was in the form y equals mx plus b. M represents your slope or your rate of change. In this case, it's $5 per ticket. The y-intercept is the b, and that is where we would be starting. In this case, it's what the cost of the DJ is going to be. Now we're looking for the profit. The profit depends on the number of tickets we have. So profit is our dependent variable, which is our y. The cost of each ticket is $5. So 5 times the number of tickets we sell. Our profit, we have to subtract the $300, which is the cost of the DJ. And that would give you your profit for the dance. Now suppose 123 people bought tickets. What would be your profit? Well, we've got 123 tickets that are sold at $5 a piece. And then we have to subtract the cost of the DJ. So we have 615, subtract 300. Our profit would be $315. So slope-intercept form can be used in a situational question, which you can then find profit. You find number of tickets sold if you had a certain profit. You can find break-even point. There's lots of things you could use. Suppose the profit was $350. How many people bought tickets? So we have our equation. But this time our profit is $350. We want to see how many tickets would have been sold. So we're solving for T. We are going to add 300 to both sides. 650 equals 5T. Then we will divide both sides by 5. And we have 130 equals T. So they sold 130 tickets. Could the profit be exactly $146? Well, let's find out. Let's put 146 into the profit. And let's solve for T. So we're going to add 300. So we'll have 446 equals 5T. Divide by 5. We're going to get 89.2. Is that possible? What T represents is the number of tickets sold. Is it possible to sell 0.2 of a ticket? The answer would be no. So the profit cannot be exactly $146 unless you made some sort of change error or had another error along the way. But we definitely cannot sell 0.2 of a ticket. Submarines must withstand tremendous pressure exerted on all sides by the water. The table shows the linear relationship between pressure and water depth. So the first thing we want to do is sketch a graph. Now we are dealing with the pressure depends on the depth. So the pressure is going to be our dependent variable, and the depth is going to be our independent variable. We need to go up to 850. So each of these, I believe, we can go up by 100s. 200, 300, etc. So at 0, we are up 100. We could probably here go up by 10s. So at 25, we are going up 350. At 50, we are going up 600. So 1, 2, 3, 4, 5, 600. And then at 75, we are going up 850. So we've drawn our graph of this relation. So here's our graph again. What is the slope of the line and what does it represent? Well, what we need to do is we need to choose 2 points that are on this line. We know that this first one here was 0, 100, and we had a second point at 25 and 350. we can substitute those into the slope formula. So we'll have y2 is 350 minus y1, which is 100, all over x2, which is 25, minus x1, which was 0. So we get 250 over 25, and we will then be able to find our slope is 10. Now what does this represent? Well, look at what we're comparing. We're comparing kilopascals, so pressure, to the water depth. So what this is saying is that you are increasing your pressure by 10 kilopascals per meter of depth that you continue to go. Determine the value of B, that is your y-intercept. It is at 0, 100. What does this value represent? Well, what we're saying is when the water depth is 0, so when we're at the surface of the water, our pressure is at 100 kilopascals. So we have 100 kilopascals of pressure on the surface of water. So write an equation that models the relationship between the pressure P and the water depth D in meters, expressed in slope-intercept form. While our pressure is our dependent variable, we found our slope to be 10, and it's 10 per meter, so 10 at, meters is the variable. And then we started at a y-intercept of 100. So it's 10 times m plus 100. An archaeologist simulates a First Nations method of boiling water by adding hot rocks to an earthen pit filled with water. As the rocks cool and lose their heat, the archaeologist replaces them with new rocks from the fire. Suppose the water temperature rises at a constant rate. The temperature of the water at the start of the experiment is 10 degrees Celsius. The equation W equals mt plus 10 models how the temperature of water, W, in degrees Celsius increases at a constant rate of m degrees Celsius per minute for t minutes. After 5 minutes, the water temperature is 19 degrees Celsius. Determine the value of the parameter m, and what does m represent? So we've got our equation. We are told that W equals the water temperature, so 19. T represents the number of minutes. We are looking for m. So we're going to start by subtracting 10. We'll have 9 equals 5 times m. We're going to divide by 5. So we have 9/5 equals m. What does this mean? So this is the constant rate of how many degrees per minute it rises. So it may be easiest to talk about this if we divide it out, and we get 1.8 equals m. So what we're saying is it rises at 1.8 degrees Celsius per minute. How long is it going to take for the water to boil? Well, we have our equation. W equals 1.8 t plus 10, because we did find our slope now. Where does water boil? Water boils at 100 degrees Celsius. So 100 equals 1.8 t plus 10. Subtract 10 from both sides. So we have 90 equals 1.8 t. Divide 90 by 1.8. And we'll get 50 equals t. So it's going to take 50 minutes for the water to boil.